Hello, my name is Sabine Giegelmeier and I'm Business Development Manager at the Fraunhofer Institute for Building Physics, IBP, in Germany. Welcome to this video about the Lighthouse project in Chennai. In this video, we will look at how to improve thermal comfort. In the first part of the video, I will explain the basics of thermal comfort, which framework conditions are actually responsible for our perception of thermal comfort. In the second part, we will look specifically at the Lighthouse project in Chennai. We will look at what measures we can take to increase the comfort in the room. Here we focus on a case where no active cooling is used. Let us now start with the basics. What is thermal comfort? In the ASHRAE Standard 55, thermal comfort is defined as that condition of mind that expresses satisfaction with the thermal environment. Another definition says that the condition of thermal comfort is sometimes defined as a state in which there are no driving impulses to correct the environment by behavior. Whether a person finds the environmental conditions comfortable or not is subjective and different for each person. However, there are evaluation methods that make it possible to assess how many people will be satisfied or dissatisfied with a particular climate, or, from another point of view, which climate is perceived as comfortable or uncomfortable by the majority of people. Various conditions have an influence on our perception of indoor climate. We will now take a closer look at these. Normal body temperature is around 37 degrees, but varies by about 1 degree, depending on the circadian rhythm. In order to keep this temperature constant, despite strongly changing external conditions, there are various regulatory mechanisms. The metabolic rate of our body has a very great influence on our thermal sensation. This depends very strongly on the level of activity. For example, whether we are sleeping, sitting at the computer, or playing sports. The second individual parameter is the insulation value of the clothing. In terms of indoor climate, there are 4 additional parameters that influence our thermal comfort: air temperature, the surface temperature of the surfaces surrounding us, which affects us through thermal radiation, the air speed, as well as the humidity contained in the air. Our body is always in heat exchange with the environment. There are different forms of heat transfer. Radiation is one of the heat transfer modes in which heat is transferred by electromagnetic waves. It is influenced by the surface temperatures. However, the most important source of thermal radiation for us is the sun. In convection, the air is a medium that transfers the heat. This process is of course influenced by the air velocity and the air temperature. In thermal transmission, heat is transferred by the mechanical contact of 2 objects. This depends strongly on the thermal conductivity of different materials. Insulating materials should not transmit heat and thus ideally have the lowest possible thermal conductivity. However, if the heat cannot be sufficiently dissipated via radiation, conduction and convection, sweating is known to occur. In this process, heat exchange takes place through evaporation of water. The share of the particular heat transfer type depends strongly on the ambient temperature and their own activity level. For example, while evaporation accounts for only a small proportion of heat transfer at low temperatures, its share increases very sharply at high temperatures until above a certain temperature, heat transfer takes place exclusively via evaporation. Now we have gained a first overview of which individual and spatial parameters have an influence on our thermal comfort. We will go into more detail in the videos on the other Lighthouse projects. But now we want to look at the comfort conditions very specifically for the Lighthouse project in Chennai and assess what measures can be taken to increase the thermal comfort in the building. The human body can adjust to climatic conditions to a certain degree through acclimatization and adaptation. Design strategies should always take into account and be based on the location of the building and the specific climatic condition. So, let's first look at the climatic conditions in Chennai. As you can see on the right side of the slide, India is divided into different climate zones. Here, 6 climate zones have been defined. Chennai is located in the southeast of the country and in the climate zone defined as tropical, wet and dry. On the left side, you can see more information about the average minimum and maximum temperatures, precipitation and relative humidity. We see that through the year, both temperatures and relative humidity are quite high. So the biggest challenge here will be to avoid overheating. Simulations allow us to calculate in advance the indoor climate resulting from the environmental factors for the specific building at the specific location. On the right side, you can see the representation of the considered housing unit. On the left side, you can see the annual course of the calculated indoor air temperature. In the background, you can also see the evaluation scale. Temperatures in the green range are perceived as average as the best conditions, yellow as good, and orange as still acceptable conditions. Those values that lie in the white range, on the other hand, are commonly perceived as unacceptable. In this calculation example, we have assumed that there is an active air conditioning in the dwelling unit, so it is not very surprising that the indoor temperature is constant at around 28 degrees and thus consistently in the good range. At the top right, you can see an overview of how many occupancy hours per year are spent in each comfort category. Here, 0 hours are usually considered unacceptable by the user. This example should only be used as a reference case. Of course, the comfort considerations are more interesting if you calculate what the indoor climate is like when there is no active cooling. So let's see what happens if there is no active cooling used in the apartment. Here you can see a clear difference to the reference case with active cooling before. The temperature fluctuates slightly over the year following the course of the outside temperature. The temperature is consistently high. If we look at the small table at the top right, we see that about 5,100 hours are still considered acceptable. However, 1,800 hours a year are no longer in the comfortable range. So what can we do now to reduce the percentage of hours with unacceptable conditions? Since the heat input here is presumably to a large extent via solar radiation through the windows, the first obvious thing to do here is to include shading. We have done that and again calculated the resulting indoor climate. So here you can see the calculation for the case when there is no active cooling, but a shading through external blinds. Compared to the previous case without shading, we notice a significant improvement in the indoor climate evaluation. You remember, in the previous case, 1,800 hours a year were evaluated as unacceptable. Here, this number has been reduced to around 880 hours. In general, a much higher percentage of occupancy hours is considered to be the best or good indoor climate. What else could be done to further improve the comfort conditions? At the beginning of the videos, we were talking about the heat transfer types. Shading reduces heat radiation. So let's now focus on heat transmission. We can reduce the transmission through the walls by insulating them. So we made another calculation with interior insulation. Here we now have the calculation results for the case where no AC is provided, but external shading and internal insulation. The course of the year looks very similar to the previous case. And if we look at the occupancy hours on the right side, we see that the that were considered unacceptable have been reduced by only 14 hours. This minimal improvement does not justify an additional investment in interior insulation. Interior insulation therefore makes no sense here in Chennai with this type of construction. The situation is different if active cooling is to be used. In this case, interior insulation can bring great energy savings. But as long as AC is not planned, it makes little sense regarding thermal comfort. Here we see again the results of the evaluation of occupancy hours in the overview. On the far left, the case with AC, the second bar from the left without AC. Next to it without AC but with shading, and on the far right the case additionally with interior insulation. The red part shows that share of time in which the climatic conditions are considered unacceptable. Here we see again very clearly that shading can have a great effect to reduce uncomfortable conditions. Interior insulation, on the other hand, does not bring any additional improvement. To conclude this unit, I would like to summarize the main finding once again. In the first part, we looked at the basics of thermal comfort. In the next videos, we will go into more detail here. In the second part, we looked at the effect of various structural measures on the indoor climate and comfort, specifically for the lighthouse project in Chennai. In the process, we learned that in the climate there, shading brings a strong improvement in comfort. Interior insulation, however, does not generate any additional value in this construction when there is no active cooling. In the videos on the other lighthouse projects, we will then learn about other measures and examine their effect on comfort. With that, I say goodbye for this video. Thank you for your attention.